Aloha and welcome. In this video, we're going to be looking at project 12.1, the thermometer. We're looking specifically in chapter 12 at the thermistor. And the thermistor is a neat little device. It's kind of similar to what we saw in our last lesson with the photoresistor, except this time we're going to be using a thermistor to vary the amount of resistance. And that's going to be based on heat instead of light. So let's go ahead and take a look at what we're going to need for this project. We'll have our usual suspects here. Then we're going to have a thermistor. We're going to have one 10K ohm resistor, and we're going to have about 3 jumpers. So here's the component knowledge that you're going to need to know. So a thermistor is a temperature sensitive resistor. When it senses a change in temperature, the resistance of the thermistor will change. So you can use that characteristic to detect the temperature intensity as well. So there's a lot of complicated math in here. Not much I want you to learn or know. You just need to know that there's a mathematical equation here that will give us the temperature given a lot of other information that we have. So this is what the device looks like that we're going to be using, the component that we're going to be using, and this is what the it looks like on the schematics table. So here is the formula for the relationship between the resistance value and the temperature of a thermistor. And this is complex. You know, your RT over here is the thermistor resistance, given the temperature of T2 over here. R is the nominal resistance of thermistor under T1 pressure or temperature over here. Then exp of n is the nth power of E. B is for thermal index. So you can do all kinds of neat math that come down to the formula over here, which is going to show you that, by using logarithms and whatnot, you're able to figure out what your temperature is given the value coming back from the thermistor. And that mathematics will be found in our software, but this is more of a, don't worry about, creating it on your own. It's just nice to see it. So here is what our schematics look like. And if we want to look at the, so let's just go through this real quick. We're going to have our power coming off of here. It's going to go to our 10K resistor. It's going to go into one end of the thermistor. The other end of the thermistor is going to go to our 26 pin, which is our ADC, which is giving us that, analog input. And then the ground is going to go over here to ground. So that's essentially the circuit. It's not that complex, but it's pretty neat what it does. So if we scroll down a bit, we can see the code. Actually, let's go over to Visual Studio Code to see that. So in Visual Studio Code, we see that we're setting up ADC on 26. I've modified the code here just to do a temperature in Fahrenheit as well, because it gives me something nice to compare since I don't do Celsius. So we get our reading for our ADC from the thermistor. Then we go and we divide that by 65,535.0. We're turning this into a float. You can see then we're multiplying it by 3.3. And then we're doing all that magic that's necessary to determine what the temperature is using the logarithm and everything that we had shown in that previous equation. Then we can determine the temperature in C. And I, being a genius, I just do the simple 9/5, temperature in Celsius times 9/5 plus 32 conversion to get our Fahrenheit, and we're just printing this out. So we're doing that, we're sleeping for a second, then reading it again. So we're just going to read that over and over. So let's go ahead and set this thing up. I'm going to stop sharing here. So here is our handy dandy little breadboard with our faithful Pico on it. And now let's take a look at the schematics. So the first thing we want to do is we want to run our power down to our power place. So we'll go ahead, we'll set up our 3.3 power right here. Let's run it all the way down to, let's say 40 here. So we've got it in 40. Then from 40, we're going to take our resistor and we're going to place our resistor in here at 40. And we're going to run the other end to the thermistor. So let's just put this in. Let's move it over here to 45, the other end of it. So that's all happy. So then we're going to take our thermistor and we will attach it here at one end on the, let's see, just put them in adjacent ones. So we've got one end at the, over here at 40, and the other one is going to be going over to 41, or no, 45, I'm sorry, that's 45. So we're going to go in at 45 and 46. So then we're going to run the ground from 46 over. So we'll take the ground from 46 here and run this over to ground. So no big deal. Then we need to run, we've still got to run our pin over. So we've got to go and take from our thermistor, we're going to take right here, and we're going to run this over to pin 26, I believe we said. So if we go over to pin 26 right there, that should give it to us. So this is the extent of the circuit. So nothing too complex here. I'm going to have some fun with this though. So we're going to play around. Hold on, I'm thinking about it. I think I want to spread this out a little bit more. Well, no, I'll just leave it like this. Okay, so I will bring up the screen for our trusty little thermometer. And let me pull up our program. So I'm going to run this. I need to connect it first. We need to connect our USB. So I've connected it. So Pico goes from disconnected over to connected. Now if I run it, let's see what happens. Bacon. Nope, we're getting a reading here. So 73 to 75, 73, 73, 73. It's staying somewhat stable there. So if I was to put my finger on it, would that change it? Oh, it does change it. My fingers are warm. So wow, we just had an outlier there, 383 degrees. I don't think that was accurate. But you know, by putting your hands over it, you can kind of warm that up a little bit. Then if you release it, it will slowly go back down to the room temperature. So this is a neat little program that shows you the temperature. And this is something I do not recommend for any reason, but I'm going to go ahead and quit the share. And well, actually, no, let me share that back, because you'll want that. But if you look at the small screen there to see the schematics, you see that we're around 73.4 degrees. Now we're going to play with fire, which is something that I do not recommend you ever do, but I'm going to play with it here just for purposes of seeing the thing change. So you can see we're at a study 73.4. If we light a fire here, we put it down here, you can see we go up to 78, 80. We're going up higher, higher, 86, 96. So you can see that that is very responsive to it, and then it goes and drops back down. So do not do this at home. Let your idiot instructor show you that. So that was our little experiment, just to show you that we can vary the temperature and it will be responsive and show you that. So you can do it with your finger, just use your fingers to cover it, and you can get it to raise in temperature just off of your body heat. Or you can use a match like I did, which I would not recommend, because you'll end up you know, eating through your cables there, which, yeah, is not a good idea. I'm probably going to wake up somebody wondering where is the fire. So anyway, that's a great way to smell fire and not necessarily destroy your project. So anyhow, I hope you enjoyed that. I hope this is instructive. But to me, this is pretty neat, because what we've done here is we've taken this little tiny thermistor, and sure, we can you know, we can read temperature from it. But the cool thing about it is that temperature is actually what's controlling the circuit there. That's controlling the voltage through the circuit. So we can actually get a reading off of that. So yeah, this is pretty cool. So yeah, we'll continue in our lesson here. So hang on, stay tuned, and I'll see you in the next lesson. Aloha.